The beauty of adjacency matrices. Okay, I love the title of the lesson, but I'm going to change it just a little bit. The practicality of adjacency matrices. Maybe I should just say the beauty and practicality. Okay, bus line connects 6 cities, and they gave us a lot of information. And I'm not going to read it yet, but I am going to read the directions where it says create a directed, we're going to use arrows, a directed vertex edge graph with this information. And so let's just glance through it. And I'm not reading for comprehension, actually. Here's what I'm reading for. I need to make a vertex edge graph, so I need to know what my vertices are. So my vertices are Asheboro, Greensboro, High Point, Greensboro, Archdale, Winston-Salem, High Point, Archdale, Winston-Salem, High Point, Archdale, Asheboro, Randleman, Asheboro. Okay, so Asheboro, Greensboro, High Point, Archdale, Winston-Salem, Randleman. There are 6. So let's do it. Asheboro, I'll put an E at the end of it. Asheboro, Greensboro, High Point, Archdale. By the way, this is not geographically correct. Winston-Salem, and Randleman. Okay, we need to create a directed, it has arrows, a directed vertex edge graph with this information. So we read it again very carefully, and we're going to draw. So we switch colors, and here we go. You can travel on this bus line from Asheboro to Greensboro and to High Point. So from Asheboro to Greensboro, you can travel from Asheboro to High Point. Okay, next line. We can travel from Greensboro to Archdale and Winston-Salem. So from Greensboro, we could go to Archdale. We could also go to Winston-Salem. We can go from High Point to Archdale. We can go from Winston-Salem to High Point. We can go from Archdale to Asheboro. We can go from Archdale to Randleman. I'm going to go around. Not that it matters. That's not necessarily indicative of the bus line. It is indicative of the fact that the middle of this thing was getting cluttered, and I just wanted to go around. It's perfectly okay. And we're going to go from Randleman to Asheboro. There we go. So we need to write the adjacency matrix. And we can do that from the vertex edge graph. We could also do it from the words that we have here. Either way is good. So we go from the row to the column. Let me zoom out just a little bit, raise this camera up. And here goes. I'm actually going to go from here and here. So Asheboro goes to Greensboro and High Point, which makes sense. Asheboro to Greensboro and High Point. So from Ash to Greensboro and to High Point. Everything else will be a 0. I can go from Greensboro to Archdale and Winston-Salem. Greensboro to Archdale, Winston-Salem. Greensboro, Archdale, Winston-Salem. We've done this before. High Point to Archdale and only to Archdale. Winston-Salem to High Point. So we're on a different row now. It's not going in order. Winston-Salem to High Point. Archdale goes to Asheboro and Randleman. Randleman goes to Asheboro. There we go. Again, directed, which means the rows and the columns don't correspond. All right, everything else is a 0. At this point, we need to go to desmos.com/matrix and type this in. Why? Because in a minute, we're going to square it. And we're going to talk about what that really means. So if you want to go ahead and go to Desmos, you can. I'm actually going to use a graphing calculator. I just find it more efficient for me personally. And you already know how to use Desmos. So for those that care about using the graphing calculator, I'm just going to throw this thing down here. Whoa, check out that really cool graph. That's amazing. Calculus is a beautiful thing. All right, let's just kind of get out of there. I'm going to go, if you're following along on a calculator, like if you're wanting to learn how to do it, I'm going to press second in matrix. And I need to edit a matrix, so I'm going to go over to edit and press enter. I'm going to call it A. And it is indeed a 6x6 matrix. Actually, I think that's already in there. Nope, that's the wrong one. So I'm going to type what I have here. So 0, 1, 1, 0, 0, 0. 0, enter. 1, 1, 0, 0, 0. And then next row, 0, 0, 0, 1, 1, 0. 0, 0, 0, 1, 0, 0. 0, 0, 0, 1, 0, 0. All right. 1, 0, 0, 0, 0, 1. 1, 0, 0, 1, 0, 0, 0. And then the last row, 1 and then 5 zeros. Okay, once we have that, we are going to quit. Second and quit. I want to make sure that I've typed this correctly. So I'm going to go to second and matrix, and where it says names, I'm just going to press enter on A. That pulls up A, and there it is. And I'm double checking, making sure I'm good. And I'm good. No, I'm not. There's a mistake. I hope you see what I see. See that one right there? It belongs right down there. So I need to fix it. So second matrix, let's go to edit. And let's put the one where it belongs and take it out from where it doesn't. You can use the arrows and navigate. There we go. And I'm going to press enter again, which pulls up the last thing. And there it is. And that should be accurate. I'm going to take a moment and double check, because I've done this before and one mistake messes everything up. All right, so we have it in there. We'll take a moment and do what you've probably already done. Whoa! Got carried away with my zeros there. 0, 1, which technically is still 1, but it's driving me crazy, so we'll fix it. Okay, now we're going to square the adjacency matrix. What does the squared adjacency matrix represent? Okay, you can square it in Desmos if you like, desmos.com/matrix. I'm going to square mine here, so let's clear that out. Second and matrix. I'm going to press enter on A, and I'm going to square it. There it is. And we're going to copy that exactly the way it looks right there on the paper. So 0, 0, 0, 2, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Let's double check, make sure we're good. I think we are. All right. Before I answer what the squared matrix represents, let me go back up and talk about the adjacency matrix and talk about what it represents. All right. I can hop on a bus in Asheboro and get to Greensboro in one bus ride. Okay, so if you want to get technical, we called this one A. This was A. And technically, this is A to the first power. So I can go from Asheboro to Greensboro in one bus ride. I can go from Asheboro to High Point in one bus ride, right? All right, actually, let me point and say it a different way. I need to make sure I'm really articulating this differently. I just pointed at one and pointed at the wrong one. I have, this is the correct way of wording it. One way of getting from Asheboro to Greensboro in one bus ride, okay? There is one way to get from Greensboro to Archdale in one bus ride. If my graph would have looked like this, if I'd have had Asheboro and Greensboro, and there were two bus routes, then I would have a 2 here. And if there was a 2 here, then I would have 2 ways to get from Asheboro to Greensboro with one bus ride. So I keep saying one bus ride. So if I'm going to go down here and this is squared, then this is the number of ways to get from one city to another in 2 bus rides. Okay, so I'm going to write that out. What does the squared adjacency matrix represent? A squared represents the number of ways to get from one city to another with exactly 2 bus rides. Okay, so let's answer the question below. How many ways can you travel from Asheboro to Archdale with 2 bus rides. And then what are they? So I want to go from Ashboro to Archdale. There are 2 ways to travel from Ashboro to Archdale by riding the bus twice. So there are 2 ways. Let's put it in context. To travel from Ashboro to Archdale with 2 bus rides. Okay, and then what are they? Well, that's different. Now I need to map it out. I want to go from Ashboro to Archdale, and I want to take the bus twice. So, for example, I'm wanting to go from Ashboro to Archdale, but I need to stop off somewhere else and pick up something. So, going from here to here, well, I can't go straight there, but that's not even what it was asking, even if I could. But I can go Ashboro to Greensboro to Archdale. I could do that. That's one way. And here's the other way. Ashboro, High Point, Archdale. So let's draw that out. Ashboro, Greensboro, I misspelled green, Greensboro, Archdale. That's one way. Here's the other way. I'm going to put a comma. Ashboro, High Point, Archdale. There you go. All right, we're going to continue this idea. We're about to cube this matrix. So let's flip the paper over. Cube the adjacency matrix. We're going to call this A cubed for obvious reasons. So here goes. Let's see. Matrix A to the 3rd power. And we have this. There it is. It's beautiful. It's lovely. So I'm going to copy this down on my paper. 2, 1, 2, 1, 1, 1, 1, 1, 1, 1. There we go. We've copied it. I've left the zeros out. We'll deal with that in a minute. I'm double checking. Awkward pause is me just checking. There we go. All right, there we go. Done. Okay. How many ways can you get from Archdale to Winston-Salem with 3 bus rides? And the implication is it's exactly 3 bus rides, and we're going to list them. So I want to go from Archdale to Winston-Salem in 3 bus rides. There is one way. I'm not using a complete sentence this time. I should be. Let's do it. There is one way to get from Archdale to Winston-Salem with 3 bus rides. And then it says list them, but there's no them. It's just one thing. So I want to go from Arch to Winston-Salem with 3 bus rides. I only have to find one way of doing it. So let's do it. Archdale to Winston-Salem, and I'm going to ride the bus 3 times. When I ride the bus 3 times, that means I'm going to follow 3 arrows. So we just start going, and maybe we'll get there, okay? So 1, 2, 3. Nope. 1, 2, 3. That was it. 1, 2, 3. I do want to point out something, though. When we list this, we're actually going to list 4 cities, 4 bus stops. Archdale, Ashboro, Greensboro, Winston-Salem, but it's really only 3 bus rides. 1, 2, 3. So Archdale, Ashboro, Greensboro, Winston-Salem. So Archdale to Ashboro to Greensboro to Winston-Salem. Okay. How many ways can you get from Ashboro to Archdale with 3 bus rides or less? List them. Let's do that. So what I'm going to do over here on the side is actually figure out how many ways I can get from Ashboro to Archdale with 3 rides, and then with 2 rides, and then with 1 ride, and we're going to add those together. So I want to go from Ashboro to Archdale with 3 bus rides. I better be looking at A cubed. Ashboro to Archdale, that's 0. 0. I'm going to put colons there. You can put equal signs, it doesn't matter. 2 bus rides. I'm going to be squaring it, right? Asheboro to Archdale. So Asheboro to Archdale is 2. And then 1 bus ride, that's just the regular matrix to the first power. Asheboro to Archdale is 0. So 0, there we go. And then, how many ways? Well, there are 2 total ways. 2 ways to get to Archdale from Asheboro with 3 bus rides or less. Okay, this is bugging me. There, made it sloppier, but for some reason I just felt the need to write the word out instead of put the number. Anyway, just personal opinion. Maybe it's those papers I had to write in college that they were picky about those things. Anyway, I need to list them. Well, I don't have anything to list here. I don't have anything to list here, but I do have to list the 2 rides here, which actually, let's be real honest with ourselves, we've already done that. Asheboro to Archdale and 2 bus rides, we already did it. So Ash Green Arch, Ash High Point Arch. So there they are. Now, if I would have had more things here, then I would have to list them as well. So Ash Green, let's put E, Green Arch, and then Ash High Point Arch. Okay? How many ways can you get from Archdale back to Archdale in 3 bus rides? And the implication is it's exactly 3 bus rides. So we're going from Archdale back to Archdale. So we're going to list them. So let's do it. 3 bus rides means I'm looking at the cubic one. So Archdale to Archdale, that would be 2. There are 2 ways. There are 2 ways to travel from Archdale. I'm using complete sentences because it's just a really good idea. Just kind of puts things in context. When you don't use complete sentences, you kind of forget what you're truly answering. 3 bus rides. And then we're going to list them. So I want to go from Archdale to Archdale, and I have to ride the bus 3 times. So here's what's about to happen. I'm going to start in Archdale. I'm going to travel somewhere, back to Archdale. Archdale is somewhere to somewhere back to Archdale. Now, you might be like, well, 1, 2, 3, 4 cities. Nope, yeah, but 3 bus rides. Bus ride, bus ride, bus ride. And we're going to do it again. Archdale. Archdale. Okay? So let's do it. Archdale back to Archdale. We're going to ride the bus 3 times. 1, 2, 3. 1, 2, 3. That was it. Archdale, Asheboro, High Point, Archdale. Archdale, Asheboro, High Point, Archdale. There's one of them. All right, the other one is, well, I don't know. Archdale, Asheboro, Nope. 1. Oh, Archdale to Asheboro to Greensboro to Archdale. Archdale, Asheboro, Greensboro, Archdale. Okay, one more problem, same kind of thing. I'm going to go kind of fast through this one. How many ways can you get from Randleman to High Point in 3 bus rides or less? So 3 bus rides or less, that means I need to figure out how many 3 rides I have, how many 2 rides I have, how many 1 ride I have, and we'll go from there. So we're going to look at the cubic matrix, the squared matrix, and the matrix to the first power, which was the original adjacency matrix. How many ways can I go from Randleman to High Point? Randleman to High Point. 0. I don't have to find any triple rides. All right, we're going to look for double rides now. Randleman to High Point. 1. That's it. Randleman to High Point was 1. a single ride. I don't think Randleman goes to High Point. Randleman goes to Ashboro. Randleman to High Point is not a thing. And we can kind of see that here. Randleman doesn't go to High Point. So we actually only have to find one. There's one way. Let me put this down here and put it in focus. There's one way or another. I'm gonna find you. Sorry, old song from the 80s. There is one way to travel from Randleman to High Point in 3 rides or less. And then it says list them. Well, I'm only looking for a double ride, so Randleman to High Point. Here goes. Randleman to High Point. 1, 2. Randleman, Ashboro, High Point. Done. 3 cities, but 2 bus rides. Randleman, Ashboro, High Point. There we go.